Chapter 4 Electromagnetism. Let's begin. Stacking up coins. Using a strong magnet, you may also stack up some coins as in the picture. 1. Magnets. Lobestones are magnets that are found in nature. Now, most magnets are made artificially. There are different shapes of magnet, such as bar magnets, snap-shaped magnets, and ring magnets. The shape and position of their poles are different due to the action of the Earth's magnetic field. All magnets align themselves along the magnetic field of the Earth, basically along the north-south direction. The pole face that points to the geographic north is called the magnetic north pole, while that points to the geographic south is called magnetic south pole. Magnets align themselves because there is a weak magnetic field produced by the Earth, which means the Earth behaves like a big magnet. In primary school, you may have learned that two magnets interact at a distance. Magnetic force for both attraction and repulsion is at a distance. Like poles repel, while unlike poles attract. Lastly, magnets also attract magnetic materials such as iron, steel, nickel, and cobalt. They are called ferromagnetic materials. Magnets do not attract other materials like aluminum. 2. Magnetic fields. Similar to electric field and gravitational field, the concept of magnetic field is used to explain interactions due to magnetic forces. First, let's see how we may observe different magnetic field patterns produced by different configurations of magnets. Experiment 4A. Magnetic field patterns.
Using sticky tape, fix a bar magnet to the underside of a perspex board. Sprinkle iron filings onto the board and tap the board gently with a pencil. Observe the iron filings pattern produced. Place two bar magnets end to end with unlike poles facing each other. Sprinkle iron filings onto the board and tap gently to produce a pattern. Place two bar magnets end to end with like poles facing each other. Sprinkle iron filings onto the board and tap gently to produce a pattern. Place two slab-shaped magnets with unlike poles facing each other. Place a perspex board on top. Sprinkle iron filings onto the board and tap gently to produce a pattern.
The iron filings align themselves along the magnetic field lines. However, the filings cannot show the directions of magnetic fields, although the densities at different points may give some hints to the strength of the magnetic field there. Magnetic field lines start from magnetic north pole and end at magnetic south pole outside a magnet. When plotting compasses are used, they can show the direction of magnetic field at a point. Compass is actually a small magnet which points in the direction of the magnetic field line. In other words, the tip of the arrow of a compass is indeed a magnetic north pole by itself.
You can see the two-dimensional magnetic field patterns in the textbook. But can you imagine what the magnetic field pattern looks like in a three-dimensional space? I will show you the three-dimensional magnetic field pattern of a bar magnet with the apparatus shown. Put a bar magnet inside the test tube and rotate the bottle on the table. After a while, the iron filings inside the bottle will be attracted by the bar magnet and settle into a special pattern. Observe the pattern carefully. Why do the iron filings seem to assemble at both ends of the bar magnet?
Similar to electric field, the density of field lines is directly proportional to the field's strength at that point. The direction of field lines, on the other hand, give the direction of magnetic force on a north pole placed at that point, and so magnetic field lines can never cross. Otherwise, there will be two forces acting at a single point. In some cases, such as in Figure 4.1J, there is a neutral point where all magnetic fields just cancel out, and the resultant magnetic field is zero, and we call this point a neutral point. Note also that magnetic field, like electric field and gravitational field, is three-dimensional. The next video will show the 3D magnetic field pattern of a bar magnet. Example 1. Magnetic field around two bar magnets. When two bar magnets are placed with their like poles side by side, there will be neutral points formed there. On the other hand, if they have their opposite poles placed side by side, the magnetic field pattern looks like this. By the way, slab-shaped magnets have a different pair of pole faces when placed with unlike poles facing each other, and better on a steel yoke, which directs the field lines to form closed loop. The magnetic field will be uniform, and hence parallel and evenly spaced field lines are produced. 3. The Earth's magnetic field. Since compass points to the geographic North Pole, the field lines direct from the geographic South Pole to the North Pole. Imagine there's a big magnet inside the Earth. The geographic South Pole of the Earth is actually a magnetic North Pole, which produces the Earth's magnetic field lines. Do checkpoint 1 below.